All right, so last section for this week, section 8.5, geometric sequences. Okay, so geometric sequences are another form of sequences. Now, just to remind you guys, arithmetic sequences or arithmetic sequences are sequences in which the numbers have a common difference. That means you either add a certain amount or subtract a certain amount consistently, right? So maybe you have like 10, 8, 6, 4, 2, because 10 minus 2 is 8, minus 2 is 6, minus 2 is 4, minus 2 is 2, right? So if you consistently subtract 2, you get a specific set of numbers. Or if you add like a certain number consistently, all those numbers that become a list of numbers, a sequence, will be an arithmetic sequence, right? Geometric is a little different. Geometric is going to have what's called a common ratio. That means you're going to be multiplying by something. Now that something could be a normal number, or it can be a fraction, okay? So it can be either one of those. Okay, so maybe a normal number, a negative number, a fraction, negative fraction, something like that. But it's a number that you consistently multiply by. Okay? So as long as you consistently multiply by 2, or you consistently multiply by half, or by negative 3, as long as you're always multiplying by the same thing, then it's called a geometric sequence. Okay? So let me give this to you guys here. This is what it looks like. A sub n is equal to a sub 1 times r to the n minus 1. Okay? So that's usually the way it's written. Sometimes some people will write it this way. Right. A sub n equals a sub 1 times r to the n minus 1. Instead of the little dot, they'll use a parenthesis. Okay? A lot of times the parentheses are used when r is a negative number. I tend to use them all the time. I just think it looks nicer, a little bit more organized, to put the parenthesis around it. Sometimes the a sub 1 term, so it's supposed to be like a 2 or a negative 4, something like that. Sometimes that term isn't there. And if a sub 1 doesn't show up, that means that a sub 1 is a 1. That's why it's not there. It'll be like 1 times r to the n minus 1. So you wouldn't put that 1 there. So if you ever notice that the a sub 1 term is missing, it's because a sub 1 is 1. All right? And we're going to do one of those examples. I think the very last example is going to look like that. So this is what a geometric sequence looks like. And r is the common ratio. All right? So the common ratio. Remember, we just continuously are going to multiply by r, whereas with arithmetic sequences, we continuously added or subtracted d. Here, we're going to consistently multiply by that r value, the common ratio. Now, how do you find the common ratio? Well, to find the common ratio, you have to divide, okay? So, given, let's say a sub 1, a sub 2, a sub 3, a sub 4, etc. So let's say I give you 4 terms. The way you find the common ratio is, and you can do this with any one of these combinations, you can do a sub 2 over a sub 1, or you could do a sub 3 over a sub 2, or you could do a sub 4 over a sub 3. So notice it's the number to the right dividing the number to the left. Okay? So it's divided by the number to the left side. So a sub 2 divided by a sub 1, right? So you're doing right divided by left, right divided by left, all the time, okay? Don't do left divided by right, or else it's going to give you the wrong common ratio. So it's very important you guys always divide this way, okay? So you're dividing right to left, all right? But if they ever give you a list of numbers and they ask you, like, is this a geometric sequence? Well, what you do is you do that division, and you make sure that every single one has the same ratio. Every time you divide it, it should come out to the same answer. If it does, then it is a geometric sequence. If it doesn't, then it's not a geometric sequence. Okay? So, all right. So we know the formula for a geometric sequence. We know that it has a common ratio, a number that consistently multiplies over and over and over in order to get the next term. And we also know that in order to figure out what the R value is, if you're given a sequence of numbers, unless they just straight out give it to you, but if they didn't give me the R value, then I can find it by doing some division, okay? So here we go. So are these geometric sequences? We're just going to try to figure out if these are geometric sequences. By the way, you don't have to show the work to find your R value. If you could do it in your head, do it in your head. That's fine. Just make sure it works consistently. Okay? If you can't do it in your head, then just use a calculator or just work it out by hand. But we'll start off with part A. Okay? Is that a geometric sequence? So I'm going to see if the R values are consistent. So 5 divided by 3. Can I reduce that? No. So that means 5 divided by 3 is just 5 divided by 3. The next one would be 9 divided by 5. Well, I can't reduce that either, right? Are these identical? No. So my answer is no, not a geometric sequence. All right, I just started to divide. My next fraction would have been 17 divided by 9, okay? Notice none of those match. And even if 2 of them match, it doesn't matter. All of them have to match, okay? So now let's look at part B. All right, negative 8 divided by 2, that's negative 4. The next one, 32 divided by negative 8. Well, that's also negative 4. Negative 128 divided by 32 also is negative 4. So that means that when I divided, right, divided by left number, right, negative 8 divided by 2, 32 divided by negative 8, negative 128 divided by 32, my value is negative 4 consistently. That means that R must be negative 4, so this is a yes. So if you look at it, 2 times negative 4 is negative 8. Negative 8 times negative 4 is positive 32. And 32 times negative 4 is negative 128. So you can see the consistent multiplication of negative 4 within the number, okay? Each time they multiplied times negative 4. So I'll just kind of show you times negative 4 times negative 4. And again, times negative 4, right? That's how they got each number. They multiplied by negative 4 every single time. So, I mean, hopefully that's not too difficult. You're just basically checking, does it have a common ratio? And the way you're going to do that is you're just going to divide. So again, with your calculators, you can just really quick type them out and see if they match up. If they do match up, like the right type, you tell me yes, it is. It doesn't tell you to write your R value, but I would tell you to just get in the practice of writing it out. And then if it doesn't work out, just put no. And that's it. We move on. Okay, I think there's 6 problems like this. Okay, pretty easy. Just make sure you're dividing, okay? All right. Kind of like yesterday, the instructions are a little long, so I'll give you guys a little bit of time to write those down. All right, so for example number 2, the instructions say, given the first term and the common ratio. So I'm giving you a sub 1, and I'm giving you R. Okay, remember, R is what multiplies the numbers over and over. That number is going to multiply again and again and again. Find the first 4 terms. So I'm going to put first space, second space, third space, and fourth space right there. And then I know my first space should be a 3 because they told me a sub 1 is 3. And then all I have to do is multiply by 2 over and over again. So times 2. So I'm just going to kind of put that down here, right? Times 2, times 2, times 2. So 3 times 2, that's 6. 6 times 2, 12. 12 times 2, 24. And I'm done. Okay? Notice if I were to ask you, is this an arithmetic sequence? Well, 3 to 6, you add 3. But 6 to 12, you add 6. And then 12 to 24, you add 12. So that's not an arithmetic sequence. Okay? It's changing, right? But it is a geometric one because from 3 to 6 to 12 to 24, we just double it every single time. All right, so it's just times 2. So that's part A. You could see part B right here, where a sub 1 is 2. A sub 1 is 2, r is equal to negative 4. So I gave you the first term. I gave you your common ratio. Let me just write this out here. So 1, 2, 3, 4. We want 4 terms. And I know that a sub 1 is 2. So all I have to do now is just multiply by negative 4 over and over again. Okay, you don't have to write down what I'm putting down here. It's just for note purposes so you can see what happened, right? But 2 times negative 4 is negative 8. Negative 8 times negative 4, 32. And 32 times negative 4 is negative 128. We actually had this sequence earlier. Okay? Numbers can alternate. They can go positive, negative, okay, or negative, positive, negative, positive. Just depends on what's given. Usually when they alternate, it's because the R value is negative, okay? So just a little heads up for that. If you see the signs changing from positive to negative, it means that usually R is a negative number. Are we okay with these? Pretty easy so far, I hope. Okay, example number 3. I think there's only, let me see, are there only 3? No, there's 4 examples. So we're almost done. Find the common ratio and then the explicit formula. Find the common ratio and the explicit formula. Now remember, to find the common ratio, we have to do division, and we got to make sure that everything divides to the same number, or at least, divides to the same number. It can be a fraction, it can be a whole number, positive, negative, anything like that. But as long as it matches. So I'm going to go through, and I'm going to get these values that are given here, and I'm going to check them. So here we go. Actually, I just realized I didn't write this 100% correct. I should have put ... because it does continue. So let's see, negative 12 divided by negative 4, that's 3. Negative 36 divided by negative 12, that's also 3. Okay, and negative 108 divided by negative 36 is also 3. So that means all those divisions matched up. That means that my R value is 3. Okay, so I know my R value is 3. Now, they say, now that I found my common ratio, so I'm going to put that right here, put a little box around it. Let's find the explicit formula. Now, remember, the explicit formula, the way I like to write it, is going to look like this. If you don't want to put the parentheses, it's okay. Just put a little dot for times. Okay? I just prefer the parentheses. So, a sub 1 is what? Negative 4. R is 3 to the n minus 1, and that's it. You're done. All right? So that's it. So let's try doing the next one, and then we'll go to example 4, and we're done. So I give you another sequence, 100, 50, 25, 25 over 2. Again, you don't have to show the work how you find the R. Just make sure that you solved it correctly. You're going to want to test all the numbers, okay? Don't just test the first one and say, oh, I know the answer is this. Okay, it has to work for every number. So, 50 over 100, that's half. 25 over 50, well, that's half, right? 25 over 2 divided by 25. That's also half. Okay, use your calculators for that one. But they're all half. That means R is equal to half. Remember, the R value could be a fraction, it could be positive, negative, a whole number, it could be a decimal. Okay, it can be anything, any kind of number. As long as it's consistently the same number every time you divide. So half, 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 that means r equals half. Now, they want me to write the explicit formula. So a sub n is equal to a sub 1 times r to the n minus 1. Again, I write these formulas over and over again just to help you guys if you're writing this with me. It'll help you remember. Repeat it a couple times, you'll know it. So a sub 1 is what for this equation? 100. My r we just found is half and minus 1, and we're done. So like up to now, I would say that yesterday's lesson has been maybe the hardest one from the 3 that I've done. Okay, I don't think the work for these problems has been that tough. Requires a little bit of division, and that's about it, right? Maybe some rewriting of the formula, but overall it's not too terrible. Are we okay with this one? All right, so last 2. Okay, example 4A and B, I think, and that'll be it. Let me pause it while you guys write the instructions for this one. All right, so for example number 4, it says, given the explicit formula for a geometric sequence, so they gave me the formula. Find the common ratio and the term name. Okay, so find the common ratio and then the term name. So they want me to find r. This is supposed to be easy. What's r? 3, right? It's the thing that has the power on it, right? So r is 3. So all right, no big deal. And then they want me to find a sub 10. So if I may, I'm going to ask you guys to help me with this because I don't think I'm going to be able to do this in my head. A sub 10 is going to be negative 4 times 3 to the 10 minus 1. Now 10 minus 1 is 9, so that's negative 4 times 3 to the 9th power. Okay, I'm assuming that's going to be a very big negative number. Negative, right?
Yeah.
So negative 78,732. Anybody verify that? Anybody? I'm not looking. Yeah? Okay. So we got 3. So there we go. So either you're right or 3 of you guys are wrong. I don't know, but I'm assuming you're right. But yeah, negative 4 times 3 to 9, that sounds right. Okay. So there you go. Not a hard thing to do. You're just plugging numbers in. The biggest part is just making sure you use your calculator the right way, and that's it. So one more, and then we're done. And I was going to stop actually after part A, but I'm like, you know what? We didn't give them one of these tricky looking ones. So not that this one's difficult. It just looks different. So sometimes people are like, what happened, right? Just out of curiosity, what's a sub 1 for this one? A sub 1. Not 0. 1. Because if it was a 0, then the whole equation would be 0. Right? A sub 1 is 1. You don't see it in front of the parenthesis, but it's there. But remember, anytime we have a 1 in front, they usually don't write it. So a sub 1 would be 1, but obviously I didn't ask you for that in the problem. My r value is what? All right, negative 2. So I'll put a little in here. And then I got to find a sub 15. So again, I'm going to need your help here. This is going to be negative 2 to the 15 minus 1. So that's negative 2 to the 14th. If you got a negative answer, you did not use parentheses. Okay? Anybody have the answer? How much? 384. All right. That was here. But 16,384. If you got a negative answer, again, you guys, anytime you take a negative number to a power, make sure you put the negative number in a parenthesis. Okay? Or else it's going to give you the wrong answer. That's why when you plug in negative 2, or whenever you plug in, say, like a negative 2 squared into your calculator, it'll throw out a negative 4. But if you put negative 2 in a parenthesis, it'll throw out a positive 4. Okay? So make sure you guys are using the parentheses for negative numbers raised to power. All right? So I'm going to go ahead and stop right there, give you guys your homework, and let you guys work on that.